Okay, everyone, we are live. I hope you are hearing me okay. I know this room is a little bit echoey. I have done my best to fix that, but my apartment is pretty empty at the moment. I have just moved into my new apartment in a new city. So I haven't really bought a lot of things yet. Good, Bob. I'm glad to hear that it works okay. And hello, Prakar. You have to forgive me for pronouncing your name probably wrong. Thank you. All right. So today we are primarily gonna do live coding, and as usual for these spontaneous live streams, we are not gonna start a new project from scratch. We are gonna continue a project which we already started, because these streams are primarily focused to not have like 10,000 open projects and just start a new project all the time. But using these streams, I intend to finish the projects I've started. Yes, so let's see. Hello, Vinjak and Sanjay. Welcome to the stream. And you're learning Python. Python is for sure a legit language. It's not a language that I have ever coded though, so I'm not sure if I'm really to any help. Yes, perhaps I should list a couple of those projects. I can type it in the chat perhaps. So let me see, projects that are open. We have the file encryptor, file decryptor. We have the framework, and the backend, the web backend framework. Yesterday I had a stream where I continued with that project, so there has been 2 episodes as of yet. I am not done with the post production stuff with that episode, but as soon as I am, I'm going to publish the code and the recording of that live stream. Hello, Katak. Welcome to the stream. So what else do we have? Sorry about my voice. The file encryptor, decryptor, web backend. Let me open my YouTube window so I can check a little bit. So let's see, open projects. If you remember anyone, you can type that in the chat as well. So let's see, yeah, we have the database server, the one that I did a composite video about, a 10-hour video. All right, and we have the Runlock, but I need to make a working version for myself before I create any videos with Runlock, because they are like hundreds and hundreds of lines of assembly, a whole lot of it. So I need to be done with that first myself, but it's going to be a really cool project. It is probably the coolest thing I have ever coded in my entire life. If you don't know what Runlock is, it's a program which takes binary executable in Linux as an input, so basically an exe file, a program. And it asks you for a password, and then it uses that password to encrypt the whole binary file. But it does not just create a blob of data. It creates a working executable. So when you start that executable, it will ask you for the password, and then it will use that password to decrypt the file in memory, and it will then execute it without creating any additional temporary files. So it's a very good security tool, and I hope I will go through the finish line with that one, because it's really awesome. This chat messaging app, Christian, I will code something like that. I think it's a very good and interesting idea, but that's a new project, and today we are going to focus on the old. And we have the network simulator is done, but we have the network mapper as well. If you remember, that's a program which scans an entire IP range and maps up the network and its services. Let's see, the password recovery is done, the needle threads done, and then we have the database server. And after that, I think we have gone through every open project. Yes. So basically we have 5 open projects. I will summarize. We have the network mapper, the database server, we have the web backend framework, and then we have the file encryptor and decryptor. So what do you want me to focus on today? By the way, don't tell me yet. Think a little bit about that, and I will show you one thing in between. So let's see, I even made one of those table of contents type things. So let me just move this to the side a little bit and open this instead. So this is the plan for today's stream. First, some general information, which I have given some, but not everything, and some updates. And then we will choose today's project, and then we will live code. And there are 2 possibilities. Either this stream will be between 1 and 1.5 hour total, or it will be 3 hour with a 20-minute break in between. And what will decide? Well, after 1.5 hours, if you are still watching and if you want more, then I will take the break and then we will do the rest. But if you feel that we are done after 1.5 hours, then we are done. So it's basically your decision. All right. So the general info, I wanted to tell you a little bit about some of this stuff. Some of you will already know, but not everyone. So I still need to show it. This is my code repo. The link is, as you can see, on the top here. No, you cannot. Now you can. So repo.birch.com, HTTPS in front. And as you can see, there's a lock on a lot of these folders, but it works like this. When I when I publish an episode, let's say I, for example, publish episode 3 of the web backend, then I will make that folder available for everyone for 48 hours. And if you want to get any older material, then you need to become a member and you will get access. So that's why. And you might consider it cheap of me to do that way, but all my coding videos are free and will be free for always. And this is my full-time job now, YouTube. So I still need to pay my rent somehow, and I thought I don't want to restrict the videos, the coding videos. So everyone should have access to that, and everyone should have access for a while to the code. But if you want to have a permanent access and go to old stuff, then you need to become a member. And you can do that by going to https drbirch.com/support, and there are different levels, but the standard membership is like $10 per month tops. It will be even cheaper if you're in some countries, because YouTube gives discounts. Anyhow, enough selling. Let's focus on today and the project. I did want to show you a little bit about my progress with the Runlock project. That's the one I talked a little bit about just now. So in order to do that, I need to log in with my Sociopath SCP client. And in case you don't know what that is a program I have made which makes it possible to code remotely on a Linux machine, in VS Code, for example, or in any program. So it transfers files and it transfers them automatically when you save. So let's see if I can access this. I probably can't, I think, because I'm not behind that. Let's do this instead. I forgot that I'm not on the VPN currently, so I can't really do that. So let me log in to the old machine first. So it's c.birch.com, port 18. Alright, so I will show you here instead. So let me connect to my jump host, and then I will connect to my 32-bit machine. And let's see, I will go to code, to assembly, and not everything is written in assembly. As much as possible is written in C, but some of this stuff is not possible to do in C. So I made it in assembly. I'm not done with this project yet. I have created a lot of utility functions, for example. I think I have showed you these before. So I have one for reading the password from standard in and displaying stars when you type. And then and I have some helper functions. But the interesting stuff is inside of, let's see, instead of hash.asm, for example. Here I implemented an hash algorithm entirely in assembly, and it works just fine. So you supply it with some kind of input. It can be one character, or it can be like millions. And then it will do a standard hashing on this thing, and it will generate something that looks like this. So basically like this. And I did that a while back. I have told you about it. I haven't showed you the code. But the thing I wrote more recently, because I need a hash algorithm and I need an encryption algorithm for this to work. So I wrote my own RC4 implementation. That's a stream cipher in assembly, and it's almost done. It works when you call the functions from assembly, but it does not work when I call it from C. And that's because I have these wrapper functions which tries to put the stack in order before it calls the actual functions. But I haven't really gotten that part to work yet, so it crashes when I run it. But I'm working on this. And when I'm done with this encryption stuff, then I will just put everything together and add a little bit of more code, and the project is complete. And then I will give it to you guys. So that's what I've been doing the last couple of weeks, in addition to moving from Stockholm to an entire new city. Right. So let's see what's happening inside of the chat. Oh, you are active. Let's see. Can you give a small demo of that? Gupta, what do you mean? A demo of Runlock or of the network mapper, or which one are you talking about? Hello, Christoph. Database server, that's an interesting project for sure. Create a poll. Use Python to pick a random, but I don't want it to be random. I want you to decide. File encryptor decryptor, and a little explanation of that in-memory executable. Yeah. So, Gupta, Oh, thank you. I'm glad you think that, because that's I put in a lot of time in this project, and for 6 months I have gone minus every month because I have expenses for servers and stuff to make this work. So I'm glad that you feel that way. Project idea, internet speed estimator in C. That's a really interesting idea. I think I will... Hello, by the way, Ashish. I think I will add that to my list. Can you remember to remember me, to remind me at the end of the stream, please, so I can add it to my list. Let's see. Hello, Pika. Your channel and your content is very special. Congrats. Thank you. That's very nice of you to say. And this is so unique. Thanks. Osama Show. Hello. I really want to know what you're doing, but it looks like very difficult. Well, yes, it's a very advanced project if you think of the assembly code. But the actual C code that produces the output, so to say, that's not very, it's a bit complicated, but not very. And I intend to make a video when we code that C code together. So that won't be a problem, I think. The only thing in that code which is rather difficult is the file format, the ELF format, which Linux uses for exe files. Concurrent programming concepts like semaphores, I have that in my, I don't know if you have seen my thread library. I have coded my own thread library from scratch without dependencies. It's called Needle Thread, and the latest version is available through NPM, and you can also download an outdated version from my repo. I'm going to update that as soon as I have time. But that supports concurrency with mutex locks and stuff like that. But it all happens behind the scenes automatically, so the user of the library don't need to think about that. Osama Show. When you say, can you consider a beginner project, do you mean that I should suggest a topic for you to code? Or do you mean I should create a programming video about a beginner project? Hello, saddest pox. Let's continue the Cash-22 project. Okay, it seems like most of you guys want me to keep coding on the database server. Have I interpreted that correctly? Osama, I can create a video about the beginner project. I have noticed though that I feel it's kind of difficult for me to create a beginner project because it was so long ago that I myself was beginner in C. That's like 25 years ago. So I did a couple of beginner projects, like the game, for example, the Wordle game. That's a beginner project. No, almost no pointers and stuff like that. But it turned out to be very bad code instead because I had to. I don't know why actually, but I think it's due to that I'm restricted when it comes to those kind of things. But I can sure try make a video. It will be a video, but I'm not sure how good it will be. Hello, Walter. Now it's flying those hearts here. I'm not sure what that is actually, but thank you for it. Okay, so let's continue at the Cash-22 database server. Hello, Shaug from Norway. That's not far from here. Welcome to the stream. I hope you will think that our project of the day is interesting. Let's see if I can change this frame to the left here. Let's see, properties. This should be cache 22 data, cache 22 DB server. All right. Did the frame to the left of the screen change? Hello, futile lad. And hello, technical senior. Make more videos about cybersecurity or networking. I will most definitely do that. Networking and cybersecurity is the most fun thing to code, I think. So, and I do have a lot of interesting ideas. So I will for sure create that. And futile lad wants a job. How good is C++? Well, it's a legit language. It's not the language I would choose, but it's a legit language. A whole lot of people use it, both professionally and recreationally. Before we start, let me just for 1 minute show you something else. I have created a new video which I will release later tonight, I think. And I want to give you a little tease about it. So let's see if I can find the thumbnail. Okay, it filled up my entire screen. 1 moment. Now I think you should see it. So this is what the next regular episode is about. And the video is 100% complete. I will just have to upload it to YouTube. So I'll do that later on tonight. I can order Kim Jong-un at your exact GPS coordinates. Yeah. Alright, so let's begin. It was a while ago I coded on this. I have done a lot of episodes about it. You have seen a lot of them, I suppose. I also made a composite video with the first 5 or 6 episodes, I think. But there are more. But my point is, I need to read a little bit about the code together with you first. Are you planning on doing some more assembly videos in the future? Yes, I am. When I reached 10,000 subscribers, like, I don't know, 1.5 months ago or something like that, then I got the exact same question. When should I continue the assembly school, which only has 1 episode, which is about registers. And I made a promise to that guy that when I reach 20,000, I will continue that series. And I can't see right now how many I have, but I would guess somewhere around 19,960 or something like that. So perhaps we will reach 20K in the middle of this live stream. Wouldn't that be something? All right. So let's let's begin. I'm gonna start by going to the directory and trying to find out which. Let me go to the server this way first, so I can figure out what folder has the newest version of the code. Let's see, it's on Code Planet somewhere. Let me reattach my screen first. Let's close this. Like this. Alright, so let's see. It's probably somewhere in the TMP. And what do we have here? Cache 22. We have a directory, and then we have cache 22.1. What is that? Okay, that's just an empty thing. What else do we have? Needle, netmap, password recovery. We have one for the tree as well, because the binary tree is a part of this project, but I don't think it's very up to date. It's probably this cache 22 thing from June 28th. Let me just check real quick when I released the Hashtable episode, because that's the latest in that series. So let's see. Hashtable project, coding a hashtable from scratch, and that's from the 12th of July. The 12th of July. Here is July 1st. Let's search for all directories in this path, which has a file called cache22.c. Only that. What if I do the same thing inside of this directory? Okay, we have one here as well. June 17th. Let's see. Hashtable. It pretty much gotta be this one, but I'm not sure why the date is not the same. Perhaps I released that video a while after. Is that possible? Let's see if we have the hash table here. We do not. This is kind of educational as well. If you're not familiar with the grep commands and find commands when you're searching in multiple files, this is a great way to do it. This command with R and I as options will search for the word hashtable in both lowercase and uppercase. so it will find all the files which contains that word. No. Yeah, let's do this. I'm not sure that I have this exact string though, but I think I will do that. Maybe some of you, while I try to find this directory, could check real quick my Hashtable video and see if you can find it. Or maybe we could do that together, perhaps. I'm not sure if I can show you any sound through this, but let's see. So it should be somewhere inside of course, YouTube, Hashtable, and let's sort by size. Yeah, this is the one. So let's see. Need to open it with the QuickTime player and resize it a bit. Let's see. A linear search is very slow because it has to traverse the entire tree. Hello, nameless monster. Long time no see. I'm glad to see you here in the stream. Welcome. And hello, Aga1 as well. Let me see if I can see what directory I go into. Well, we are going to get into the details, but birch tree. Let's see if I can find that. No. But never mind. Let's code on the database server part of it, because there's two parts. It's the database stuff, which is an in-memory database designed as a binary tree with a hash table on top. And we will not focus on that today. We'll focus on the commands and stuff for the actual database server, because you can connect to the server and run different commands. So let's start at least in that direction, okay? So let's begin. Where did I put my sociopath? And let's go to the TMP here, and then we go to the what did I call it? Cache 22. This one, yeah, this is the one. So in case you haven't used this program before, it's a sociopath SCP client. You can right click on the directory and choose open in editor. It will download everything, and each time you save, it will automatically update against the server. So let's see, I should close this, close folder, and then I will make this the correct size and put it on your screen. Open the file. I hope this text size, the font size, is readable to you, even you who are watching from an iPad or something like that. If it's not, you need to tell me so I can fix that. So let's see. I can do something like this, I guess. Okay, this is pretty good, I think. So let's see what we have here. It was a while ago that I even looked at this code, and I'm not sure if you have seen this episode recently. What happened now? Oh, thank you, Gupta. For the, what's it called? Is it a super chat or something like that? He bought a cup of coffee for me. I really appreciate it. Thank you. Hello, Nikita. You're very much welcome. I think it's fun to create those videos and live streams, and you guys cheering me on makes it all worth it. So thank you right back. Hello, Abdel Rahman, if I pronounced it okay. And Alexander Zikal, hello. Yes, I'm glad that you are learning from me. Alright, so let's see what we got. We have the two files here, which are the actual database server stuff, and that's the cache22.c and .h. So the H file is pretty self-explanatory. We have removed this string operation truncation warning because my code triggers it without, it's a false positive. It's not a problem, but it's annoying to see all those. So that way you can use this pragma and say that this type of error should be suppressed, and then you push that to the, I don't know, to the stack of different error messages, I guess. Alright, and then we have the host and the port. We have a structure for a client. We save the socket file descriptor, the IP, in dotted decimal form in a string. And then we have the port in an int16. We have a callback function here, which is an int32, and it takes two strings and one client. It's a name, a wordplay on the book Catch-22. Well, it's, yeah, you could say that. Not at the book specifically, but at the phenomenon of Catch-22s. And since this is a cache server, it only exists in memory. It doesn't save anything to the disk, and it's thought of being used as a cache. So that's why I found it to be kinda funny to use that word. Alright. We also have this command handler thing, which takes a command as a string, and then it has a handler as a callback. And the handler is basically this function. So the general idea is we're gonna ask the user for a command, then we are gonna search the command in our internal database in between quotes. So it's just C code, but it's a database in a sense. And when it gets a hit, it will launch this function. So each command will have its own function, and it will be launched as a callback. And then we have some pretty basic stuff. We have a zero function, we have a main loop for the main server thread, and we have a child loop for the child thread or fork in this instance. We have an initialization function for the server, and we have a main which basically just does the initialization and then loops the main loop and the child loop. Okay, so basically you can get a pretty good idea about the whole program just by watching the H file, at least if you have designed it properly. I think you should put in a lot of effort on the H file before you write one single line of C code inside of your .c file. Because if you start by defining all of these structures and data types, and you give them good names, and you have a good system, and you make good signatures for the functions, then you can very easily just continue on by creating functions which makes use of these different data types. So if you have trouble designing a bigger program, or you want help by doing it, then this is a very good way to start. Let me just take a couple of sips of water. That's interesting, Eric. He made a discovery. Let me show this on the screen. If you look in your repo in the tree directory, the birch tree directory is a subdirectory. That's interesting. I can't really go into the secret part of the repo at the moment because I don't want the link to be publicly available, but I can check the same on my server. So let's see, if we go to let's go to this, and then perhaps tree 2, or maybe it's a cache 2. In this I don't have one. Let's see, in the code directory. I usually distinguish between code and this TMP thing, because the TMP thing is where I code on camera, so to speak. And this code directory is my own stuff, basically. Alright, let's see, birch utils, we have to the catch-22 directory. No. Let's search for it. And let's put up the chat. If we move it, there we go. Foo temp tree, birch tree. Okay, I would never in a million years have found that. So let's see, we go to foo. What is this? I don't even remember foo. Seem to have some stuff here. That's weird. Anyhow, let's go to the birch tree. Let's go to the tree. No, where was it? My memory is not what it used to be. Okay, so we have TMP tree, birch tree, and we have foo TMP tree, birch tree. All right. Huh, look at that, July 11th. Thank you, Eric. So that's great. Then we can, I think the best way would be to, let me see what's in there first. Yes, it's a hash table. Is it a standalone hash table or is it the actual code? Example gen hashes, hash naive. Okay, so we made the hash table stuff its own project basically, and we have some kind of function that tries it out and populates a hash table. Let's see if it works to begin with. In file, out file, right? So let's see, let's do the, it's possible to do the 50k, I'm not sure what limit we set for the hash table. Oh, it's 23. Alright, I'm not sure what's gonna happen really. It probably did something with the output. Okay, so here we see the actual hash table. So the thing we see to the right is a lot of different English words and stuff from our in file. And all of those has been added to the hash table. And the thing to the left is the hash, I suppose. Right. So in case you don't know what a hash table is, perhaps I should explain that first. So let's say we have a binary tree structure. So it's, you can imagine a lot of different connections of data from here to there and stuff like that. And when we search that, we need to traverse the whole thing. Let's make an example with just a line of data. So let's say we have ABC and CDE and EFG and HIJ and so on and so forth. And let's say this is a database. If we want to search for this HIJ, we must first go to ABC, and then go to CDE, EFG, and then go to this one. So it takes a lot of CPU power. Let's say you have a huge database with like 50 million entries or something, then it will be totally impossible to go through that much data in this way. So how can we do this better? Let's say we were to manually, let's say all these four are static data, and we want to just make a static thing which accesses those pretty quickly. So what we want is basic. Let's say we make it as an array. We define an array of strings. So something like char db 4. And we need to make this pointer. And then we just do something like db0 is equal to Isn't that annoying when you access the wrong key and you need to type the whole thing again? So db0 is equal to dd4 big P. There we go. Some VI magic. And let's say we set this to ABC, CDE, and EFG, HIJ. And this will be 1, 2, 3. I hope everyone is with me so far. This is pretty basic stuff. We just create an array of strings and we assign each and every one of them to this static piece of data. If we want to access HIJ in this kind of structure, then we do not need to go through every single one. We can just access that by typing db3, and it will jump to that location immediately. So this is a much better way of accessing the data. It goes very fast. But the trouble is, how do you know the index? So that's a thing which is solved by the hash table. Because let's say, for example, that we have some basic form of hash function which takes a string as an input and it will produce a hash. And let's say the hashes look like this. So basically 2 bytes of data in a hexadecimal form. And let's say, for instance, that if we hash HIJ, it will become 0x99b2, for example. What we do is we change this 3 right here to this number. And this is a pretty big number, somewhere in the range of 30,000 or something like that. How do I know that it's 30,000 out of memory? Because 2 bytes is always 65,535 at most, if we take the index. And a hash beginning with a 9, that's basically halfway through, a little bit more, because it goes all the way to F, which is 15. So maybe in the 40,000s, but could be 30,000s as well. Let me just copy this so we can check later on. Alright, so if we replace all of these indices with the hash that's generated from the string, that way when we want to access anything in the database, we just take the string we want to search for, like hij, we feed it into this hash function, and it produces 0x99b2. Then we use that index, that hash as an index to directly index into this data. As you can see, the hash table needs to be quite big because it needs to have room for this number and probably even bigger numbers as well. So that's one drawback. A hash table takes more memory than a regular list like this, but it is a lot faster if the database is big when accessing the data. So that's a hash table 101 in like, I don't know, what could it be, 5 minutes? And let's see if we do a decimal version of this. No, that's the wrong server. Let's do maybe we can just do this echo. We do that. Yeah, 39,000. That was pretty close. Okay, so now we know enough to continue with this project. Maybe I should, yeah, let's copy this location before I forget it. So it should go to my home, and let's see, where are we currently? I think we're inside TMP and cache 22. So let's move the whole shebang there. And then we go to that directory, TMP cache 22. No? Ah, 2. There we go. And I will, no, what happened there? I will set my home environment variable to the current working directory to make things a little bit easier. And now we have, did I go to the wrong place now? Or did I copy to the wrong place? To TMP -22. Okay. This expands to the current home directory, not my real home directory. So let's see if we can find the right thing. Right. So let's copy it again. It was inside of foo and tree, or TMP and tree. merge tree. Alright, there we go. Sweet. So let's see what's happened in the chat. Why callback in the struct is not a pointer? Alexander Segal, it will be a pointer, but let me show you why I do it this way. So let's see, where did we have this? Inside of VS Code. Right, so here is the type definition, but it is a pointer, right? Yeah. So this is what I wanted to show you. I thought it was like this. And when I do it like this, it's so I can put the star here and show inside of the structure that it really is a pointer. But since I put the star inside of the type definition, I don't need to have a star here, or I can't even have a star here, because it will automatically be a pointer since we have the star here. Do you understand? Alright. I think it's pointed to another struct which has a pointer. Use a hash map for indexing. That's right. What are the drawbacks of this hash map indexing approach? Can't think of any except additional storage required for storing the hash table. Yeah, it's that is basically the only drawback. But we have one scenario that I didn't talk about, and that is collisions. Since we are using a limited number of bits to create those hashes, two different strings can result in the same hash. And that's a problem, because then it will jump to the wrong thing, right? So what can we do about that? Well, we can choose a hash algorithm that has as few collisions as possible for our type of data. So different types of data, different file format, for example, has different algorithms which deal with them best, so to say. But we can never get 100% rid of the collisions. So the standard way of dealing with it is, if you get a collision, then you add one to the index and you try basically the next one. So this is when you create the hash table. If you find a collision, then you will add one to the index. And then you will add one to the index if that position also is populated. And then you go until you find something which is free. So that makes it a linear search, basically, the thing we're trying to avoid. But it's not a linear search of the whole database. It's only a small part of the database. So basically from the index of the collation to the first whole. And also, not everything collides. It's maybe 5% or something like that, which needs to do part of the search linearly. However, I haven't finished that project, by the way. It's a part of this project. So basically, I'm gonna create 2 or perhaps even 3 different hash tables of varying size. So first one which is really huge, then one which is like 10 times smaller or something, and then 1/3 which is 100 times smaller than the first. And then you simply do, when we create the hash table, if we're trying to insert something which collides, it will move to the next hash table and put it there instead. Yeah. And if all of these steps fail, then we will need to do a linear search. That is a general thought of it. Anyway, I haven't tried it. So let's see. Okay, now can we safely handle collisions with linear traversal? Well, let's see. I guess so. I don't really see. So if we traverse from the collision place and we go down 1 step at each iteration, we compare the hash. Let's see. We calculate yeah, I think we can, actually. Since you're asking it that way, it almost feels like I'm missing something, but I don't think I am. Yes, you can handle the collisions with a linked list, but as I mentioned, we are trying to avoid those linear those linear operations, because this is not just going to be a cache server, a database server. This is going to be the fastest in-memory database in the world. That is what we set up as our requirements, because this whole project was based on this. If we go to Google and we search for Redis, and we go to their homepage, and we try to get through the pop-ups. It's so goddamn annoying. Let's see. They don't have this anymore. Before they said something like the fastest in-memory database in the world or something like that. So that's why we wanted them to change it to our. So we wanted to create the fastest in the world, faster than Redis. So they would change it, but they have already changed it. I wonder why. Perhaps they caught wind of our project, got scared, and removed it from their website, so they weren't going to be humiliated when we beat Redis. That's the most probable scenario, I think. LND might be bad. When we hit a collision, we create a new hash table for that position and use a slightly different hashing algorithm. So now we have a second. Yes, exactly, Gupta. That's what I said. I wanted to try to have 3 different levels of hash algorithms. I mean hash tables, and I'm going to use completely different hash algorithms in the different ones. I'm going to use this what's it called, DJDNSB or something like that on one of them, and I'm going to use another one on the first, and so on. So yes, hello PNG, welcome to the stream. Do you have tips for a beginner trying to learn coding? Yes, watch my videos. No, but seriously, do that. If you go to the tutorials playlist on my YouTube channel, let me show you instead of just talking about it. So let's see, youtube.com/@Dr. Jonas Birch. I think you have all seen my page. Still 19,900. I hope it will turn 20k during the stream. That would be pretty awesome. Alright, so if we go to the playlist, it shows the spellistor in Swedish here for me, but playlist for you most probable. And I have cleaned up here a little bit. Before I had a lot of stiff stuff here. So now we only have the assembly, the tutorials, the C projects, the network technology, and the Learn to Code C. And I would start with going to the tutorials. No. So let's see. I need to click on some small thing there. Alright, so do this first, the 3-hour composite video, the beginner course. This will teach you all you need to know about the basics of C, and you learn it all in 3 hours. Do all the examples manually as well, so you learn to get real code experience. When you are done with this 3-hour course, then I would suggest that you try one of my beginner projects. So let's see. I have a project which is called, let's see, it's a game. This one, the Wordle game. I deliberately made that game in a beginner style code. So not any advanced pointers and memory operations, etc. And I have used a lot of the built-in C functions in the standard C library. So start with the Wordle game, and there's a sequel to that somewhere. Where is it? Wordle game. Ah, there it is. Finishing our game in C. So it's a 2-episode project. When you're done with that, you can do the read next line challenge. That's also a beginner project, this one. How to use C to solve the get next line challenge. That's very good to do. And then you go back to the tutorials. I'm almost done with this. You go back to the tutorials, and you you do this one, the 7-hour C programming course for advanced. There you will learn all the advanced, or a lot of the advanced things in C, like memory and pointers and yeah, all that stuff. And it's a 7-hour course, and there's a project at the end of it. So it's like a 5-episode project in it as well. So that's a good way to learn programming. And C is the best language to start with as well. Alright, so let's see. Best book I ever read was Extreme C. Good idea, staying there. YouTube making you watch an ad on your own video. Yeah, that's pretty funny actually. Is there not ad guard for Safari, or am I just dumb? I don't use ad guard. I think I want to give the author of the video the commission on the ads. Can I use Linux for your course? Of course you can. I'm using Linux 100%. Which Linux is the best? Well, there are like hundreds of different Linux distributions, and it depends on what you're going to use it for, but my favorite is without doubt Debian. Yes, most Linux distros will out-of-the-box support C, that's true. Okay, thanks bro, I'll do that. I really want to know Linux T for malware. I think it's cool. Yeah, well, if you're gonna code, well, security tools, C is the language for you, most def. I'm hyped for the next operating system video. Whose operating system video? I'm not sure I ever created one. That depends on what you mean by operating system video, I guess. Mind if you would start. Okay, so let's see. The time is, we're 1.5 hours in, and we haven't coded a whole lot actually, but we will, don't worry. So, what do you say? Shall we take a 20-minute break and continue for a while? Or are you guys tired and want to go to bed right now? Continue. Yes, Mashiro, I think you interpreted that image the wrong way. Let me show it to you again. It's this one. So it basically says that we are going to code our own build system. That's not an operating system, that's a well, it's basically something which lets you define templates and stuff for your code. At least in this project, because I have noticed that in my videos I write the same code every video in the beginning, the first like 15 or 20 minutes. I always create an H file which looks basically the same, and I always create a make file which is basically the same. So we are going to be coding a build system that will fix that. So basically it will create a template and substitute the things that we need. And yeah, that episode is done, and I will release it later tonight. But perhaps we should code an operating system. I have not done that because it's rather, what should I say? It's a little tedious and boring to watch as a video. The stuff when you create like the bootloader and stuff, that's pretty interesting. But then when you go to the BIOS interrupts and stuff and try to access files on the file system and tries to print things on the screen, then it becomes a lot of different file formats and put that number inside of that register, and very much repetitive stuff, which is not really suitable for video. That's at least my take, and that's why I haven't done it yet. But I can do it if you want. However, I have decided that I will do an episode, or perhaps several, most definitely several, about coding my own virtual machine. So that's pretty similar to coding an operating system. It's just the other end of it, so to speak. And that will be a very interesting video series, I think. Alright, Alexander thinks 1 hour is enough. I don't know if you mean one additional hour or 1 hour total, because we have exceeded that already. Gupta, no, not like Make. Perhaps I will let it evolve into something like Make, but at the moment the project is more like an add-on to Make that creates the make file, so to speak. So kind of like that thing where you type in /configure. Alright, but it seems that most of you wishes me to continue, so I will do as I planned. I will take a 20-minute break. I need to eat something. I haven't eaten more than a sandwich, like early in the morning today. And then I will be back, and we will actually start producing real code. Sounds good? Alright, so see you in a bit, guys. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, everybody, we are live. We are back from the break. And as I mentioned in the chat, thank you so much, Alexander, for joining our membership program. And we are very happy to have you. You will get all the info needed later on. And hello backend, welcome to the stream. And as I mentioned, Nikita, I will for sure create more videos on the topic of cybersecurity, because that is a topic which is very warm to my heart, as we say in Swedish. Okay, so are you guys ready? Have you filled up with caffeine and food and stuff so you can last for perhaps an hour or something? I'm sure I have. I'm not sure if we should get right on to the coding or if I should wait for some affirmation from you guys. I think we'll go directly to the code. Alright, so let's see. If we go to our directory, what do we have in here? We have a couple things, but the most interesting thing is the cache 22 thing. So if we start this one, what does it give us? It gives us some memory address and nil. So what does that mean? If we go into the actual C code for the project, let me just double check that this is alright. Yes, it's still connected. That's one good thing about the Sociopath SP client, by the way. You can connect to the server and you can remote edit your code, and then you can close the lid on your laptop and wait 14 days and get back to your computer, and it will still be connected to the server and linked up with everything. So it's the program doesn't have a lot of functions, but what it does very well. I have spent a lot of time making it fast and reliable. Anyhow, let's go to the C code. So here we have it, and let's go to the main and see what we are printing. So we set x equal to get command, and then we print the pointer to that string. Okay, so get command is basically simulating that we are giving it a command inside of the server, right? So let's see how it handles stuff. This is the main loop. It accepts a connection. It takes care of the port and the IP address and put them in the correct format. Logs something, allocates memory, and then it runs the child loop on the fork, and it breaks off the command. And what does it do with it? Alright, so what it does is it takes the command and it divides it up in a command, the first word, folder, the second word, and the rest of the arguments. So if we remove this temporary stuff inside of the main, which just prints the pointers and things like that, probably it was some kind of debugging step that we added. I don't remember really, but looks like. So I will simply comment this out, and then I will do make clean bit, clear the screen and run make. And it compiled without any warnings or errors or anything. That's good. And if we start this thing, okay, we are compiling the wrong thing. I must have overwritten the make file. That's a little bit annoying, but let's do this manually then. So gcc cache22.c, and we want it to be a cache22 binary. We want O2, we want WO, and we want std equals c2x. I'm not sure if we need some external library, but we'll see. Unused variable x. Okay, we don't need to deal with that at the moment. Alright, so let's run this again. Server listening on localhost, port 12049. So, since this is an ASCII type protocol, like HTTP and like SMTP, we can simply use the telnet tool, which basically opens a TCP connection, and we connect to that port 12049, and then it says connected to cache22 server. So let's issue some kind of command then. So let's say, for instance, that we want to put into users logged in. No, let's do this. Users and my username, and then some true or something. So this is basically what you might use a tool like this for. Either you want to use it as a cache server, which basically caches some of your, I don't know, some of your calculations or similar, or you can use it to deal with the sessions. So when you log in to a website, a session will be created, and some database needs to take care of all the different session IDs and map it to the correct users, etc. So this can be one such thing, that users and my username, if this is true, then it means I'm logged in. Something like that. So we do this, and it breaks off the put command, the folder, and the arguments. And if we were to do something like this, this shouldn't be, it will, let's say for example, ABC, everything will be added to this argument list. So it doesn't cut after 3 words, it will put the rest inside of args. And the commands that I want this program to have is basically this put command, which adds something or updates something if it already exists. I will also have a get command, which only takes 1 argument, and that is the folder and the key to the thing we want to get. So basically, the path is a folder structure, and then at the end a key. So you can think of it as directories and a file or something, but this can contain any string, basically. So in this case we don't have any arguments, we just have the get. And then we will probably need something like make directory, so we can create the folder structure. And I guess those commands are the most important ones. So we can put something in the database and we can get it later on. Okay, so this is a pretty good start, I think. We have dealt with all the parsing and things like that, which might be a little tedious to get to work sometimes. Let me just take one quick look at the chat. Yes, Gupta, I will most definitely do that. And I'm glad you liked the stream, and sleep tight, and I hope the rest of you stays with me a little while longer. And we are also logging all the connections inside of this server. And how does this work? How does it break off these strings and parse them? Basically, we wrote this stuff before. We have this, let's see. Alright, we put everything inside of this child loop. We could have made it a little bit better organized perhaps, but this works perfectly fine. First we are checking through the string, looking for a space, and then we just string copy everything. We replace the space with a 0, and then we just string copy the thing before, and then we do the same twice more. So pretty simple thing. Let me see what would be a good way to take it to the next step. Because now we have the command, we have the folder, and we have the arguments, and we do also have this command handler thing, which takes a client and it takes 2 strings as arguments. So we can just pass everything to this. And in order to do that, we will need a, let's see, we will need a command handler array. Because I don't think we have set up anything like that. Handle hello. Maybe we did. Yeah, here it is. So this is the array. At the moment it does only have one function. It basically has 2 parts. It has a string part and it has a function name part. So if this is the command, i.e. the first word that the user puts in, then this function is called, and it will automatically send the client, so the client's information, and the 2 arguments, the file path and any additional arguments. And how does it take care of this? I'm not sure that it does. Let me see what happens if I issue that hello command. So let's connect to our server again. I can never remember that port number. 12049. 12049. And if we say hello, no, we haven't implemented that part yet. So let's do it. We have all the utility functions necessary. We have this. What does this get command do? It takes a callback. So it takes, no, it returns a callback. Oh, okay, so this is the one that searches this structure. So we give it a command as a string, and it will simply go through this array, do a string compare, and in case, let's see, if it's the same, then we set the connect back to that specific handler and we return it. Alright. So all we basically need is to call this get command and call it with the right arguments. And those we have because we have them all here. So let's just create one of these, a variable, a connect back variable. And what did we call it? It's a callback. So, and it was a pointer, right? Yes. So we need a callback. And let's call it CB. And we will set the think we will do this, and then we let this move back here. Okay, so we'll set CB to be equal to our get command function, and we supply it with the command string. And if CB is 0, we will print some error message to the socket, and we'll say something like 400 command not found, and then the command. Like so, and then we simply return like that. Yeah. Otherwise, we want to call that callback function which the get command returned to us in CB. And how do we want to call it? We want to give it 3 arguments. We want to give it the client. We want to give it, we don't need to give it the command, because the command is already dealt with. It has already selected the right function, and the function is tied to the command. So the only thing we need to send is the folder and the arguments, and then we return. So not a lot of code was missing for this to work. Let's see what happens if we run it now. What does it say? Oh, I edit the typo. An exclamation point in front of the string, so it would invert the string or something, I don't know. Let's see, no, not that one, this one. So we do, let's just jump down a little bit and run the same again. Okay, now what? S undeclared. What's the name of the socket file descriptor? I usually call it S. Okay, it's inside of the client, and the client contains the S. Alright. So let's go to this and add the CLI, and I think that should be it, right? Yeah, now it's only complaining about the X. So let's start this server again. Cache 22. Let's connect to the server at 12:049. And let's issue something like not a command. Command not found, not the command. And let's say we say hello database. This time we did not get the error, but we didn't get anything else either. Oh, we did actually. Hello database. Okay, so it echoes right back what we said. Okay, it works. That's pretty nice. Now we can just worry about implementing the different commands. Right. So what do we need to do now? We need to use our binary tree so we can add stuff. Let's see. I think we need to create a proper makefile. Let's see, tree, cache 22. Okay, this hasn't updated, that's good. So if we just add something to it and save, we should get it right here. Good. So let's do make clean. Let's jump down a little bit and run make. Okay. So now we have linked it to the tree and no errors. That's great. So how do we use this tree? Create node, find last, create leaf. Right, so we have leaves and we have nodes. So nodes are basically, maybe I should show graphically somehow how this is organized. If I just add something here, and let's say we have this. So node links something together, and leaf contain data. So So the nodes don't contain any data, they're only there to link to the other stuff. So basically we have a couple of nodes. We have the root node at the top. Like so. And then we have node number 1, which is basically, so if we set the path afterwards, so the root node is slash. The first node is the first folder, and then we have the next level, and we have node 2, which might be folder 1 slash folder 2, and so on and so forth. And every node also, it links to the other nodes, both downwards and upwards, but it does also contain at the same level let's do it like this. A long arm like this. And this arm contains a lot of branches like this, and each of those is a leaf. And each of these contain one string of data. It can be a pretty long string, very big, but only one string. And if we want to access, for instance, leaf number 2, we will access that by doing get and then folder 1 slash, no, I think I have some problems with the keyboard today. Get slash folder 1 slash leaf 2, and then I will get out the data inside of it. So this is how the database will be organized. So the nodes, they link upwards and downwards to other nodes, but they also have this long arm with different leaves. And it can be infinitely long, this arm. That's why we also need a hash table, which basically creates one entry for every leaf. And then we can access them directly instead of going through this tree every time. So that is the general idea of this project. But before we start dealing with stuff like hash tables, we should at least make it work with a regular linear search in the tree structure. And we are already linking with this code, so all we need to do is to use it. We have even defined the tree, the first node of the tree, the root. So what we need to do is create another node. And by how we do that is using the create node, and we give it the parent, which in this case is the root, and we give it a path, and that is the folder-like structure. So let's try it out. Let's go to the main function and just no, not main loop, main function, and let's comment this x out. We need to define a node n, and we do n equals create node, and then we give it the parent. And how do we easily access that parent? I think we need to do this. External node root. It was a while ago I worked with several different translation units, but I think it's the right one. So now we should have access to the root from the other file, and we probably want to send its reference. Let's see. And now we need some kind of folder's name for this. So let's do users like I did previously in the example. And let's for now just print the value of n. Verify that we really do get a tree back, a node more specifically. Okay, didn't like that. Why doesn't it like that? Extern node root unknown type name node. Okay, so I didn't include that tree.h, did I? We have the cache22.h, and inside of that we do not have the tree.h. That's right. So let's do that. Create node. Declaration of function create node. Implicit declaration. Okay. What's the name of it then? Create node. And doesn't the I need to check the tree.h. No, it doesn't contain any function signatures. Alrighty. So how do we get those in an easy enough kind of way? Let's see, I think we just need to go through this file. So we have the zero function, but we already have that in the other one, I think. Then we have create node. So it returns a node. Its name is create node, and it takes another node and a string. What else? Find last linear. I think, yeah, we need to do that as well. Find last linear returns a leaf, and it takes a node. So leaf find last linear, and it takes a node. Then we have create leaf. It takes a node, a string, and an int 16, and it returns a leaf. So leaf, what did I call it? Create leaf. And it takes a node as a parent. It takes 2 strings and an int 16 for the size. I think I did that correctly. Node, string, int 16. And that's it. Okie dokie. Let's see what it says this time. So we make clean, we jump down a little bit, we clear the screen, and we run make. And it still complains that something. Okay, parse error. Happens to the best of us. Let's see. 228. No. Am I in the wrong file, perhaps? Yes, I am. 228 is this line. And it complains about signedness, and that is because I use int 8, int 16, int 32, etc. And this is a regular string. So I need to cast this into an int 8 pointer in order to get it to work. Okay, that's better. Let's see. Warning relocation against root is read only. In function main, undefined reference to root. Undefined reference to root. Undefined reference to create node. This is just a warning. This is an error, I think. Undefined reference to create node. It should be in the H file, right? Did I misspell it or something? Create node. It is right here, but did it? Node, create node. How can that be an undefined reference? Let's see. What do we have in this directory? We do have a catch 22.0. We have the tree.o. If we do nm on the tree.o, we will see everything that it's every symbol it exports. Pretty function 3. Find last linear, create node, create leaf. It's there. And how is the make file done? We compile, let's see, when we do the cache 22, we run cc with the flags, and we take the, we just take the cache 22 when we make this. Okay, that makes sense. So let's go into the code. Let's go into the makefile. And what do we want to do here? We wanted to have an additional dependency, which is the tree.o. So if we this time do the make clean, we jump down a little bit and we run make. What did you get now? Multiple definition of 0. Okay. Multiple definition of null pointer. Multiple definition of main. Well, we do not need a main inside of the tree. So let's start by pruning that branch off. It's just because this main is only for testing purposes anyway, so let's just comment out the whole shebang. Okay, so that is okay. And where do we use the null pointer? If we start with the tree, let's see. Where is, okay, so null pointer equals 0. And what do we have inside of the cache 22? Null pointer. Nothing in the H file. And nothing here as well. So if we run nm against the cache 22.o, and we grep for null, it's still there. Where does it come from? Is it something we include, perhaps? What do we include right here? stdarg, stddef. Do we really need those two? Perhaps they define the null pointer. Okay, only one error is let's alter the makefile a little bit more. It's trying to create an elf binary out of the tree as well, and we don't need that. So let's see, this thing we can just remove. Cache 22. added the LD flags variable because I was referencing it, but I didn't have it. It's still empty, but it looks better. So this time I think we are okay. No? Okay. And it still runs this. Why is that? Didn't I save? Alright. And boom. No? Why does it run that command? It's not even in the make file, right? Aha. Since we don't have a target for the tree anymore, we deleted that, it will just default and compile that like this. Like so. That must be the case. That's the only thing I deem probable or even possible. Okay, so by all accounts it should work this time, right? No, now we get another error. So we are longer in the path, or how we should express it. In function 0, multiple definition of 0 and null pointer. Didn't we fix that? No, we didn't. Okay, so let's see. Inside of tree, we define the null pointer ourselves. Inside of this, we don't, but we probably include something that does. I'm not exactly sure. Maybe it's a part of the C2X standard. So C defines the null pointer for us. That's one possibility, actually. In that case, we could just remove that part from the tree and it should work anyway, right? Let's double check. Do we use this null pointer in any signature or something? Not here. And not here. Okay, then this should get rid of one of the error messages, I suppose. Okay, now we're getting somewhere. Return null pointer doesn't work anymore, for obvious reasons, but it doesn't seem like C is defining it for us either. Note an expansion of macro return error. Undeclared. Yeah, okay. So what does it collide with? If we do grep -r -i null pointer, it should be an I here, in all the C. The keyboard is not with me today. In all the C files and all the H files. The only thing we get is this return statement and this definition. So why does it collide? If we do nm on our cache 22.o and we grab null, we did get something, right? No, we do not. So how can it possibly collide? That's what I want to know. Any ideas, chat? Perhaps try renaming null pointer to something else. We can try that. Let's see. What did I change now? Okay, so this is the thing we commented out. So let's call this 0 pointer instead. And we create a 0 pointer that we call we'll call it 0 pointer. And it points to 0. We do also need to go and change, if we search this file for null, which file is, because something returned it, right? Is it in here? Yeah, okay. So we have this macro return error, which sets the error number and then returns a null pointer. Alright, so let it return the 0 pointer instead. And let's see if that fixes anything. Make clean. And we run make. Multiple definition of 0 pointer. And it says it's first defined here in cache 22.o. But if we do nm on cache 22.o and we grep for 0, okay, now we get something. Now I think I understand. That's a tricky one. Okay, so listen to this. It has to do with how the different steps are performed. We are including this .h file, which basically means we will create this, and I'm talking about cache 22. Cache 22 is including, as we can see, the tree.h, which means we get this from the h file. And then when the preprocessor step is done, the compilation step is done, and it's about to link those different files together. This tree.c is exporting the 0 pointer, and we are trying to import it, but we already have it because we include it in the .h file. So that's why. And there is a pretty simple solution to this. What we can do is we can go to the, let's see, we need to go to the C file, and before we include the tree, we need to define tree. And just to make it obvious, we go to the cache 22 and we undefine tree. And I suppose you know the step I'm gonna perform next, right? Any ideas? People in the chat, what are your thoughts? That's right. If def and if not def. So we can, at the preprocessor level, do conditionals. And since we, in our tree.c, defines tree, and not necessarily, but we even so undefines tree right here. We could delete this, but this makes it a little bit more obvious. So now we just go to this stuff and we do if tree is defined, we perform these two steps. Otherwise we don't. And now at least that error should be gone, and hopefully every error. Yeah, almost. We have this zero function to deal with, but that's an easier way. That's an easier thing. Let's see, which of these files have the best zero function? So we take an int 8 and the size. We just loop through and we zero it out. Okay. What do we do in the cache 22? Let's see. Well, basically, character by character, it's exactly the same. So, let's see. I think it's better to get this from the tree if we have to choose. So in this case I will simply just delete this thing. And I should probably update the .h as well. And that's all she wrote. What do you say, chat? You want to see something compile? Boom. No! What happened? Oh, just a warning. Implicit declaration of 0. Yeah, we should have kept it in the... No, we should add it in the H file of the tree. That's right. It's just a warning, but I don't want it. The warning, that is. So let's go right here and we do, I think this is a void function, I don't remember. So void 0, we take an int 8 pointer and we take a 16-bit size number and we return nothing. Is that correct? It is correct. So chat, do you want to see something compiled without warnings? Boom. There we go. this is how it's done. Hello, Paige. Do you use Mac? Yes, I use Mac. But I do all the coding externally on a Linux server. But as a workstation, yeah, I use a Mac. I think I really like when I do video editing and graphic stuff, it's good to have a Mac, I think. That's right, Gupta. I never include the last semicolon when I define macros in an H file. And if you think about it, let's see, like this, for example. How do we call this function? Let's say we would have this at the end. And we call this probably by doing return and return error. And no, we just do return error and then some value like 5. And we have a semicolon at the end when we call it, right? But how does this expand? Well, it will be replaced by those 2 lines. The x will be changed to 5. And what will we have? We will have a double semicolon at the end. Yeah, and see, a double semicolon doesn't change anything in the code, but it's for my own vanity. So you could do it like this, like this, that you don't include it when you call the macro. But I think this looks weird, so I rather keep the semicolon here. Alright, so let's continue. Yeah, exactly, Gupta. I have some thoughts like that. I want everything to look as nice as possible, even though only the preprocessor will read it. Or the compiler. Alright, let's see. Where were we? We have done the troubleshooting so much I barely remember what we were doing. But we did create part of a tree like this. Let's create one more node and 2. And we link this. We call the create node function again. And instead of giving it the reference to the root node, this time we give it n, the first one that we defined. It's this one. And as an argument, we will do an int 8 star, and then let's say this is users and my username. I don't remember if we just put the current level here or if we put the whole thing. This would be less optimized, less memory optimized, but perhaps CPU optimized. But let's try this and see what happens. And let's do this again. but with N2. And let's just make a clean exit afterwards. Perhaps we should free them, by the way. Not that it matters, but once again, I want everything to be clean. Alright, let's compile this thing. And hopefully, if everything works, we should get 2 memory addresses, and they should not be the same memory address. Okay, that looks pretty nice. The only thing changing are these 8 bits. So we do get a pointer back, pointing towards the memory of our tree. Nice. Next thing will be to create a leaf to that tree, to one of these nodes. And let's see how we do that. If we go to the tree, there should be a create leaf. Okay, we need to give it a parent, that's no problem, and then a key and a value and a count, and the count will be in relation to this value, because it will allocate a structure for the leaf itself, and it will allocate a string on the heap for the actual value itself. And why do we do that? That's because this should be able to be very long. Perhaps we want to take a whole database and make it a JSON file and put inside of that one entry in the database. That should be possible. That is the general idea. Alright, so let's create a leaf. Why we didn't use the strtoke? Well, I don't like that function. I dislike that you call it one way first, and then you use the arguments differently the other times. I don't like that it keeps a state, a global state, and I like creating my own functions for things. I consider it not cheating, but something along those lines when you use a lot of other people's libraries. The standard C library is of course allowed, but especially in my videos, I try to avoid it because I want to show what's really going on under the hood. Alright, so let's see. We need to create a leaf. And we'll do that inside of cache 22. So we need to define a leaf. And we do also need to have, no, we can put all the strings in statically. Alright, so the L should be equal to create leaf, and the first argument is the parent, and the parent in this case will be the first node, N. Then we have the key. So let's say we can use that example that I used earlier today, that we will have something like, let's say we have logged in, and this should be an int 8 pointer. Then we will have the value. By the way, let's put it in its own variable. It's not much of a hassle. So let's call this p for pointer, and we set it equal to true. And it should be like this, right? And let's also have something for the size. And this time I will actually call a library function. So we need to make this an int 16 that we call string length, and we supply the char version of p. So now we have our value and its size, and that's what we give this function. So the p and the size, and let's see that we can do something like this. N tab, and this is N2 tab, and then we have the L. Let's see what we have. Alright, we did get a unique address here as well, which means that it worked. So now we have built a very simple binary tree consisting of the root level, and then the user level, and then /users and my username. We have created a leaf which contains the value, in this case true. So we have all the different bits and pieces, or not all the bits and pieces, but quite many. We just need to assemble these different pieces in order to get a working database. And when we have a working database using this linear method, we need to focus on the hash table stuff and make it optimized as well. Because remember, this database, Cache22, will be the world's fastest in-memory database. It will beat Redis. And I think that's enough for one day, don't you think? So, do you have any comments, questions, anything? Let's beat Redis. Yeah, that's right. I think we can. Should we implement a way to differentiate between a leaf and directory? You mean like if we have a node with a path /users /Jonas, and we have a leaf with a key Jonas inside of that node. Is that what you mean? Zinedine, not a clone, another in-memory database, a better in-memory database, and faster in-memory database. So not a clone, it's a similar project. But yeah, it's my goal with this is to make people move away from Redis and start using Cache 22 inside of their websites and stuff. Hey Eliphaz, what do you mean a better way to learn? Are you asking for my take on how to learn C from the beginning, or? Yeah, Prakar Gupta. Yes, we should probably do that, right? Or do we really need to? Let me think. Can any problems occur if we don't distinguish? I don't see any problems, but I can imagine that there could be problems. And it's unambiguous, or what's the word? But yeah, we should definitely make it impossible to create something with a same name. That's a good point. Let's see. How do you learn a new language or new technologies? Well, nowadays, back in the days, I usually read a book or something. I still do. I read books when I need to improve on my language. But I think watching YouTube is really great for learning programming languages. I am currently trying to learn Haskell, for example. And I've read one book about it, but I've learned most of the stuff through YouTube channels. Gupta, no, as I said, I think you are right. We should make it impossible to create a file with a directory name, or the vice versa. Zenedine, don't put any pressure onto yourself. I basically just do like this. I don't plan to learn a language. I resisted learning Haskell for long, but I still watched videos about it. And after a while, I just had to try, and it was the most difficult language I have ever tried to learn. But it's a beautiful language. It's hard to describe it in any other terms. It's like maths. Everything just flows. I don't know how to describe it. Okay, I don't know much about this Go language. And I have probably never heard about Elixir. But yeah, soon you can use webdev.c instead. Any other questions? Any comments about today's episode? Did you like it? Okay, Gustav, I'm glad to hear it. Even though we spent half of the stream not writing any code. Yes, I feel exactly the same. And when I don't feel joy, I have a lot of trouble making myself code anything. It's been a little bit different since I started this channel, because now I code all the time, right? But before, I really had to be in the exact mood in order to make any great code. And I have coded JavaScript as well. I think since ES6 it's a quite powerful language, especially if you write it in the functional style. That sounds pretty cool. Anyhow, I think I need to call it a day now. You have been a great audience, very much questions and comments, and I like that because it gets more fun for all of us if we have a good interaction, even though we might not produce as much code as we would have. But having fun is the important thing, right? All right. Thanks for watching, guys, and we'll see each other very soon. Take care. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support.